We are very fortunate on this Earth Day to have some important people come and speak to us. The first speaker I want to introduce is Dr. Kai. And Dr. Kai has a very, very interesting job. She actually studies the composition of the Earth's deep mantle through volcanoes. I don't know anyone else in the entire world that does this. I don't know if you do, but this sounds so interesting to me. So she's going to talk about her work. She is currently a teacher at Columbia University. She teaches a course called The Frontiers of Science. So please give a very round, warm welcome to Dr. Kai.
It's my great pleasure to be here. Let me see if I can turn on my presentation. Okay. So I'm here to tell you a story today. A story that scientists tell each other. But it's a different kind of story from probably most stories you usually hear, because it's a story that nature is trying to tell everybody, especially the scientists, but only those who pay attention will understand the story. So today, I hope you will listen to the story and become a scientist like me, okay? All right, the story is going to be about the climate on Earth. I'm going to hopefully explain well what climate is, and probably all of you guys, some of you guys probably heard the term global warming. Oh wow, I'm impressed. So I'm going to explain to you what global warming is. It's a kind of forecast. A forecast is something people do to try to predict what's going to happen in the future. So global warming is a kind of forecast of the climate on Earth in the future. So why do scientists think the Earth will become warmer? And well, as we just walked out of the cold winter, we're entering the warmer spring. Why do we worry about it? Wouldn't it be nicer to be warmer? This is a question for you to think about. But let me first introduce two of my friends. Can you see the screen? So these are two girlfriends of mine. One of them is Anna, and one of them is Tina. Anna was a student at Hunter College Elementary, just like all of you. And Tina is her cousin. She's visiting from Key West, Florida. Any of you have been to Key West? It's a beautiful place, right? So Tina is visiting Anna, and it's a Sunday afternoon. They were supposed to go to the zoo, but unfortunately it was snowing outside, and it was a big snowstorm, so they had to cancel the trip and then stay at home instead. And that's true. Anna sneezed, and Tina said, "Oh, let's turn up the heat. I don't want you to catch a cold." But Anna stopped Tina and said, "No, don't turn up the heat. I'll just put on my sweater. Professor Macaulay told us to watch out for our carbon footprint." Then Tina was really confused. What are you talking about? How would turn up the heat make a footprint? So, what is a carbon footprint? What is Anna talking about? Well, so when we talk about carbon footprint, it's kind of a footprint you cannot really see, okay? It's a footprint made up of a kind of gas, carbon dioxide gas. I'm going to use my magic wand to point to it. So this is the carbon footprint we're talking about. So whenever you burn something like wood that's made of carbon, or charcoal, or gasoline, or natural gas, you get heat from burning these carbon-rich products. But as you're getting energy from it, there's something else that sneaks out of the wood and goes into the atmosphere, and it is carbon dioxide. And most of our energy resources in this figure, about 90% of our energy resources goes through pretty much the same process as burning wood. You get energy from it, but at the same time, these materials give off carbon dioxide into the air. So why do we have to watch out for carbon dioxide? Well, let's see what our protagonists are saying. Tina thinks it's silly to watch out for carbon dioxide. Let's see what she thinks. Her teacher told her, Tina said, carbon dioxide is good for us. Without it, the Earth would be much colder. It would be like on the moon. Oh, the moon is really cold. We don't want that. So how does carbon dioxide protect us or warm us up? So this slide will show you how it does that magically. So during the day, when it's a sunny day, even when it's cloudy, the sun heats up the Earth through its light. And this light goes through the atmosphere. Some of it gets reflected out, but some of it is absorbed by the Earth. So Earth is, lying in the sun, you can put it that way, and absorb all the heat sun can give it. But at night, what happens? What do you think? What does the Earth do at night? Yes? Yes,
On the other side. So the other side is getting the heat.
You're right. One side of the Earth is always warm.
And he can't get through the Earth.
Yes, he cannot get through the core of the Earth, so he warms up one side of the Earth. During the day of our time, it warms up our northern hemisphere, and at night it warms up the southern hemisphere. East and west. It goes east and west. So at night, our night, the Earth where we're standing on is cooling off, right? It's there's no sun, it's night, so it's giving off heat. So when the Earth is cooling off, some of that heat goes up to the air, and it's trapped by the carbon dioxide in the air. So in a way, carbon dioxide in the atmosphere is like a blanket. It's like a blanket you put on yourself at night to keep yourself warm. So what happens if you put on too much blanket? Yes. You become too warm, right? And we think that's what happens on Earth. And let's see if we're right. First, let's look at a few extreme situations. So this is Venus. It's our neighboring planet. And most of its atmosphere is made of carbon dioxide. So it has a really thick blanket all around it. So what happens on Venus?
So I guess
It's really, really hot, right? Anyone helps your mom cook turkey in the oven ever? Yes? So what's the temperature you usually put on the oven to cook a turkey? Anyone know? Just shout out the answer. About 360 to 350 degree Fahrenheit. So this is about more than twice as much. So you wouldn't want to live on Venus. So our neighbor is kind of giving us an example that too much carbon dioxide in the atmosphere is not good. It makes us too hot. So what if we have no carbon dioxide in the air? So our moon is another example. The moon is really close to the Earth, so it receives pretty much the same amount of energy from the sun, but the surface of the moon is really, really cold. It's minus 50 degrees. It's 50 degrees below zero. It's colder than any of the freezers you have in the house. And you definitely don't want to live there. So let's see what's on Earth. Well, on Earth, there's just a little bit of carbon dioxide, but just enough to keep us warm, to keep the water as liquid. That makes us a blue planet. And water gives rise to life. So we're blue and green. And Tina was right. Without carbon dioxide, the Earth would be a lot cooler. It would be below zero, below freezing, and we don't want that. So why do we worry about it? Why do we worry about our carbon footprint or how much carbon dioxide we add into the atmosphere? So first, let's look at how big is this footprint. We know that too much is not good, right? So this is a figure that shows you how much carbon dioxide there has been in the past. And this record is from the ice drilled in the polar, in the North Pole or South Pole. It goes from today back all the way to 400,000 years ago. It's way before civilization. And as you see, the content, how much carbon dioxide there was in air, hasn't been really constant. It goes down and go up, go down and up and down and up. But pretty much it stays within this gray band. And let's see what happened when we, humans, came into the picture. Boom! In the past 50 years, we've increased our carbon dioxide content in the atmosphere by almost the same amount as how much it's been varying in the past. So it kind of looks like we added another thick blanket on us. Okay? So let's see, where did those footprints come from? Well, about a quarter of it, this is a pie chart. So each slice of the pie shows you the size of the slice is proportional to how much each piece represents. So this is a big piece of the pie. About a quarter of the pie come from electricity, heating. When you turn on the light, somewhere in the world, someone is turning wood or coal or fossil fuel into energy. And as they're doing so, they're releasing carbon dioxide into the atmosphere. They're adding more blanket on the planet. And another process that adds carbon dioxide to the planet is by deforestation. If you cut trees, trees are made of carbon, and they hold on to a lot of carbon in their mass, in their leaf, and the trunk. But if you cut those trees, they'll slowly decay away and give back the carbon dioxide to air. So that actually contributes to a lot of our carbon footprint. So deforestation is not good. Another part of our carbon footprint come from agriculture. So when you eat meat, grains, meat especially contributes a lot, adds a lot of carbon dioxide to the atmosphere. Also, as some of you may know, when you drive cars, you use gasoline, right? Gasoline comes from very ancient trees, trees that died millions and millions of years ago and somehow was preserved. So when you burn these fossil trees, and we call it fossil fuel, you also release, you get energy from it, but you also release a lot of carbon dioxide. You're making a carbon footprint. And another piece of pie comes from manufacturing, factories that make your clothes, furniture in the house. So all of these things we do every day, and we cannot stop doing it. We have to somehow keep these things going so we can go on living, but all of these things make up a huge carbon footprint. So in fact, every single one of us, you and me, on average, we contribute about 20,000 pounds of carbon dioxide into that atmosphere. And that's like 2 big elephants. That's a lot, right? So what would happen if we do nothing about it? If we just continue living as usual, driving a lot, and wasting a lot of food or wasting a lot of products or deforest, cut down forests, what will happen? By the end of the century, scientists predict that we're going to have about 2 or 3 times more carbon dioxide in the atmosphere. And what would that do to our climate or to weather over long term? It's going to make the Earth warmer by about 5 degrees Celsius or 9 degrees Fahrenheit by the end of the century. So this is the moment that I'm going to ask you, why not? Think about it. Why not? What would happen if the Earth is warming by 5 degrees?